today is our last lesson before this test. Okay? 3.6, polynomial and rational inequalities. Now some of this might look a little familiar, but there's a lot of new stuff in this one. Okay? Not a lot of theorems, which is nice. It's just a lot of solving. Okay? We're going to solve polynomial inequalities and rational ones, and solve applications that involve both of them. So here we go. Quick little definition. So let f of x be a polynomial, then an inequality of the form f of x less than 0, f of x greater than 0, and then we'll do the same thing with the equal to symbols. It's called a polynomial inequality. Okay. Now, how do we solve a polynomial inequality? Instead of me writing all the steps down and have you guys write every word, I'm going to give that to you right here. Okay, so that we have a handout, has all the steps written for you. If you want to write them in your notes, you can. I just wanted to give you that option. Okay. But I'm going to go ahead and demonstrate in this example, those steps. So here we go. Solve inequality. Before we even solve it, we want to set it equal to 0. Okay, so that means pull everything on one side of the equation to make it easier. Let me distribute this first, and then I can combine some terms. So x squared minus x greater than 12 plus 3x. So we'll smooth the 12 and 3x over to the other side. So we get x squared, this will be a minus 4x now, minus 12 greater than 0. Sometimes you get lucky, sometimes it's already written that way, but in this case, we had to move some stuff around. Now, looking at this, what you want to do next is figure out when is this 0, right? What x values give it to be 0? And can we include it if that's the case? No, but we still need to figure out what makes it 0. So let's set it equal to 0 and solve. So this inequality sign, I'm going to ignore just right now. I'm going to solve by factor. So the factors of negative 12 that add to give me negative 4, that's negative 6 and 2. When I solve for each one, I get 6 and negative 2. Okay. Now that's when it's 0, right? And I don't want it to be 0. But the question becomes, when is this guy, when I plug an x value, bigger than 0, right? Now we can graph it and actually see visually what that looks like. But what we can do instead is just draw just a little line over here. And we call these like boundary points. So we have a negative 2 and a 6. So that's where it's hitting the x-axis, right? So what I'm going to do is test points here, here, and here. And when I'm testing a point, what I'm looking for is, when is it greater than 0, the y value? That's all I'm doing. And it's my choice as to what points I want to pick. So for this one, I don't know, I'm going to pick negative 3. the test. Here in the middle, why not 0? That's a nice one to pick. And then over here, I'm going to pick a 7. Okay, so -3, 0, and 7. So let's plug those in. So let's plug -3 in. Okay, we'll plug it right into here and see what my output is. So when I do that, I get 9. And let me just highlight, I'm plugging it into this guy. That's the inequality I'm trying to figure out here. So that's a positive value, right? Is 9 bigger than 0? It is, right? So that's a good thing for us. Underneath it, I'm just going to write what that means for us. So at that point, the function's greater than 0. Next, let's plug 0 in. Well, that's easy. -12. Plugging 0 in, those cancel out. That's negative. Well, is that greater than 0? No. So we're not going to be including those answers. But underneath it, I'm just going to write that's less than 0, just to keep track of things. And the last one, let's plug 7 in. Okay, so when we plug 7 in, we get 9. So that means it's greater than 0. So that's another thing that we want, right? So let me go ahead and highlight this right here. So this is good, and this is good. That, not so good. Okay, we only want values that are bigger than 0. So what intervals are we considering? Well, we're considering this and this. So when I write my solutions, I want to write my solution set as a range of values for here and here, but not in the middle. Does that make sense? Okay, so let's do that. I'm going to put it here. I mean, you guys are probably going to write it beneath all your stuff, but I'm going to try and keep it on one board. So this, at that interval is going to be -infinity to -2. Now I'm putting a parenthesis there because we don't want it equal to 0, right? And that's what this is saying. If it's -2, it's equal to 0, that's no good. So parentheses. Union with, okay, now we're picking up with this. So I don't want to include 6 because again, that makes it 0 and that's not part of the inequality that we want. And all the way to infinity. Okay, so there's my answer for that. Any questions? And again, you're just testing points out. I just try to pick the easiest ones. I mean, we got lucky here. 0 is a really nice, easy point to test. Let's try another one. Solve the inequality. Now we got a x to the 4th in there. That's okay. That's no biggie. We'll handle it. Just like before, I want to set it equal to 0. I'm going to move everything over to the other side. Typically, it's better if you just have the leading coefficient stay positive. So I mean, I could move this over, but let's just bring everything else to the other side. It's nice to keep the leading term positive, just for calculation purposes. So this is going to be x to the 4th minus 14x cubed plus 48x squared less than or equal to 0. Okay. Now, I just want to find when it is 0. And when I find those answers, I'm going to include them, right? In this case, I will, because it's an equals to symbol. So how do I solve this? Well, we got methods. We have our ways to figuring this out. And what I'm thinking about doing is this. I know they have an x squared in common, right? Let me factor that out. So we're going to factor an x squared out. So I get x squared minus 14x plus 48 equals 0. That looks a little bit better, huh? Set each of these equal to 0 and solve. Well, the first one's just x squared equals 0, so x has to be 0. Okay? And I'm going to include that answer, right? Because if I go back to the inequality, we're allowed to include answers that give me 0. The other side, I got lucky again. I can factor by grouping, or not grouping, just factor normally. So I can do x minus 8 and x minus 6. That gives me 48 when I multiply and negative 14 when I add. So we have x to be 8 and x to be 6. And again, I'm allowed to include those ones because inequality says include values that give you 0. But I'm not done yet. I want to find the range of values too, right? That also make this less than or equal to 0. Just like what I did over here, I'm going to go ahead and just plot those on a generic number line and just pick intervals. And find points in those intervals and see what they give me. What does the y values give me? So let me just draw this over here. 0, 6, and 8. And let's pick some points. So for this one, I'm going to pick -1. In between here, I'm going to pick 1. Why not? Pick smaller numbers. In between the 6 and 8, well, pick 7. And then after 9, or after 8, I pick 9. Now I can plug in each one of these into here and just see what happens, right? Is it going to be less than 0 or greater than 0, and go from there. But what I could do instead, I was mostly concerned with the sign, right? So in this case, if it was positive, this was good. If it was negative, it was bad. So instead of plugging those numbers in and getting an answer, what I could do instead is just focus on the signs. And really not worry about what it's equal to. I just want to know if it's positive or negative. So I'm going to show you a different way of doing this. By the way, you can do this for every single problem, what I did over there. But here's another method that you can use. Okay? So what I'm going to use is this right here. Okay? And I'm just going to focus on the signs. So I'm going to just do a little table. So an x squared, okay, x minus 8, x minus 6, and at the very end, I'll put all three of them together. Okay. And we have 1, 2, 3, 4. So 1, 2, 3, and 4. So instead of me coming up with, like, if I plug -1 into it, I get this answer, I'm just going to worry about the signs. Make it a little bit easier that way. So if I plug a -1 into here, that's positive, right? So we'll put a plus. If I put a -1 into here, that's going to remain negative. If I put a -1 into here, that's going to be negative. Again, I'm not really concerned. Oh, I have an extra parentheses. That's weird. I'm not concerned with what number it gives me. I just want to know if it's positive or negative. Now, the last step, that's weird. I had an extra parentheses here, but none here. My brain's doing great today. So for the last step, if I multiply a positive and two negatives, what's the answer going to give me? Positive or negative?
Yeah, positive.
Positive. Oops, wrong color. I'm using red. There we go. Make sense?
Mm-hmm.
Okay. Now, is that good for our function here? No, right? We want negative values, less than 0. So, in other words, am I going to include those answers?
No.
No. Does that make, are we okay so far with that? Again, if you want to plug the whole number in, you can. It's no big deal. All right, next step. If I plug a 1 in, well, that's still going to be a positive number. A 1 into here would be negative. That'll be negative. I think we have another positive. We multiply them all together. So 7, plug into the first one, you get a positive number, you get a negative number. Oh, hey, I get a positive number this time. And if I multiply a positive and a negative and a positive, I get a negative. Okay, so this is good for us. Negative numbers, that's less than 0. So it looks like, what, our third interval? So right here, looks pretty good. I'll put a little star there. But let's test the last one. Maybe it works down here. So if I plug a 9 in, that's positive. 9 into this guy gives it a positive number. That's a positive, so multiplying all three together gives me positive. So this is the only section, our third interval, so I'll just shade it. That's the only part where our solutions are going to work. All those numbers, if I plug it into my inequality, will be less than 0. So far, so good. So everything else I'm going to ignore. So my solution set is 6 and 8, but I have to include 6 and 8, right? Because it has an equal to symbol. I'm allowed to include them because it gives me 0. But doesn't 0 also give me that as well? I can't forget that guy. I can't leave him behind. So we're going to union it with 0, okay? So I still have to include it because 0 still gives me a true statement there. we did two examples there. One example where it was just plug a number in and is it greater than or less than, and one where we just the signs. You know, just looking at the signs, can we figure out what are the solutions? Okay, let's try another one. So this is plural, solve inequalities. We're going to do a quick inspection approach when it comes to this. So we're going to solve all four of them. But not, this is going to be weird, but not in those methods. This one I can solve rather quickly, and I'll show you what I mean by that. When you have a polynomial, specifically a quadratic like this, if the first value is a perfect square and the last value is a perfect square, then we can factor it, okay? And it's going to be the same factor twice. So let me just put this up here. So 9x squared plus 6x plus 1 factors into 3x plus 1, 3x plus 1, which I'll combine it with an exponent and make it square. So that's what it simplifies to, just basic factoring. So let's look at part A for a moment. So I'm going to write underneath it what this actually is. Okay, so for part A, that's actually 3x plus 1 squared less than 0. Well, let's be smart. Is this ever going to be a negative number?
No.
You're squaring it, right? I don't care if the parentheses end up being negative. You're squaring it. So are we ever going to have an answer for this guy?
Mm-mm.
Nope. So my solution set is empty. Nothing in it. So sometimes we get lucky. Sometimes we get something like that that we can solve rather quickly. So over here, let's do it again. So 3x plus 1 squared less than or equal to 0. Now this is a little different. We already know that it's never going to be negative. But we have an equal to symbol. Can this be 0? It can't, right? So here's what we'll do. Let's set it equal to 0. Okay. I'm not going to put the square there because I'm more concerned with what makes this 0, right? Because if you square 0, you get 0. So this is going to be negative a third. Does that make sense? So that's the only time when this is 0. We already know it can't be less than that. So my solution is negative a third. Part C. Let me rewrite it again. This is just 3x plus 1 squared greater than 0. Now let's think about this one for a moment. Is this always going to be positive? Yes. So is it always going to be greater than 0?
Mm-hmm.
Yeah. But there's no equal to symbol. So what x value am I not allowed to have?
0. Or whatever makes it equal to 0.
A negative 1/3, right? Does that make sense?
Yeah.
So I don't want to include it. Every other number is allowed, but that one. So my solution is going to be a little different. So it's from negative infinity to negative a third, union with negative a third to positive infinity. So that's me excluding the negative third. I'm not putting a bracket there because I don't want to include it. Last one. So this is, again, let me rewrite it. So 3x plus 1 squared greater than or equal to 0. Now for this one, it's allowed to be 0, so guess what? That's good. And we already know that every number I plug in, because we're squaring it, is going to be greater than 0. So I think it's all real solutions, huh? I can do anything I like. So this would be negative infinity to infinity. Those are all my possibilities for that guy. Okay. Any questions? Awesome. All right, moving on, maybe. Am I losing it? I had a whole stack of notes here. Did I drop them? I am losing it, right?
Losing some.
I literally had them all in my hand. I'm losing it? Like, seriously, I just had the whole thing in my hand, and now they just disappeared.
The other board.
That is weird. Seriously, I'm losing. Did I pass them out to someone accidentally when I was passing out those papers?
I don't
No?
have one.
They have one?
It's
Had in my hand.
behind the side ones here, maybe. Yeah.
I think so. Oh, this is strange. This is crazy. This will be the title of the YouTube video. Teacher went crazy. Can't find notes. Nothing up my sleeves. What?
Justin.
What's my paper, man? What?
Wait.
This is not your.
Oh.
Huh?
It's not my paper. They were on my desk when I came and I was loaded in my chair.
That's what they are. Okay. Ta-da!
I was like, I wonder if he's passed these notes.
Wow.
Guys, I
There's
should
no
Justin,
more.
bro.
There's still. There's some more. This is incriminating,
Justin, why would you say anything, bro?
Oh my
Because
gosh.
if we don't do it today, we're not letting you review for the final.
Wow.
Yeah.
We're gonna have to review.
Alright, we got it.
We got him.
Guys, I tried.
We're back in action.
C is the one that fell.
Jeez, that was so. I really thought I was just gonna walk out the building and just say I can't do today.
When nobody
I
else
can't
could.
teach today, apparently.
You would have never seen that if I totally covered it.
All right. So that was polynomial inequalities. Let's talk about rational ones.
This is not a race.
Nope, it's not erasing. Man, I'm fighting the world today. Well, actually, yeah. I had a document that I've been using for years that completely just got deleted off of my Google Drive, which I didn't think it was possible to delete something off of a Google Drive, but it's gone. So I have to figure that one out too. So let f of x be a rational expression. Then an inequality in the form f of x greater than 0, same thing as before, every possibility of this. It's called a rational inequality. So we just did a bunch of graphing with them in the last lesson, but we're not really graphing in this lesson. Bless you. Solve the inequality. Now remember vertical asymptotes, like things that we don't want it to be?
Yeah.
Because it makes the whole thing undefined. So what x value do I already not want in my domain? 4. Does that make sense? Okay, so let me just put a note here. So my VA is x equals 4. Don't want to use it, right? So we exclude it. Now there's an equal to symbol here. So what could make this 0? Well, think about it. If the numerator is 0, the whole fraction's 0, right? So what would make the numerator 0? What x value? -3. So that's going to be my boundary points. Those are the points I'm going to use to find my solutions. So we have here -3 and 4. And we're just going to pick numbers. So here's what I picked. I'm going to pick up here -4. I'll pick 0 again. And then I'll pick 5. Same principle. I'm going to use the sign method over here, okay, to figure out when this is greater than 0. Okay? So let's see. We have an x plus 3. We have an x minus 4. And then we're going to divide them at the end. let's see, I got 1, 2, 3 intervals, so I need 3 of these guys. So let's plug a -4 in first. So if I plug a -4 into here, it's going to be negative. This will be negative. And then the last part, if I divide the two negatives, it gives me a positive. Okay, that's good. So that's a good interval for us. Let's continue. Let me plug 0 in. So plug 0 into here, it's a positive answer. Plug 0 into here, it's a negative. If I divide a positive and negative, I get a negative. So no good, right? We don't want the middle stuff. The last one, if I plug 5 in, I get a positive. Another positive if I plug 5 into here, and if you're dividing by 2 positives, you get a positive. So that's also good. So I'll just shade it. So this and this we want to use. But we want to keep something in mind, right? Okay, so looking at this, which number do I want to include, the -3 or the 4? -3 I'm allowed to use, right? The 4 I don't. So when I write my answer, that 4 has to have a parentheses, right? So here we go, our solution set would be -infinity to -3, including it, union with 4 and infinity. So all of those values we would need to make that true. Okay. Now, the one thing you can do, if you want to use a graphic calculator, you can, and graph it and see if that holds. And it does. Let's try and look. Solve the inequality. Yeah. Okay, looking at this problem, I still want to set it equal to 0, right? So that 1, got to move it over. Let's do that first. Okay. Well, we got a lot of fractions there. And that's a lot to keep track of, right? So it's not, I wouldn't say it's a good idea to start doing like a sign table and go from there. Instead, let's try to make it into one fraction, okay? Then it'll be easier to simplify and possibly analyze it. So to make it in one fraction, I need a common denominator. So we'll just put that over 1 for a moment. I can see my common denominator, if you go back to, like, I think it's our first lesson we did stuff like this. It'd be x minus 1, x minus 3, okay? So for the first fraction up here, to get that common denominator, I have to multiply top and bottom by x minus 3. So I'll just put here times. And then this guy, I'd have to multiply top and bottom by x minus 1 to get a common denominator. And then this lucky guy gets both. I'd have to multiply top and bottom by. Okay. Again, I'm just missing the parentheses. Like, what the heck's going on? Okay. So I get the following. Okay, so that's just me multiplying everything out. So the common denominator is this guy. Okay, so this is being multiplied together over here. These two are getting multiplied in this section, and then these two get multiplied with a -1 over there. Okay.
Boy.
A lot going on there, huh?
Mm-hmm.
So here's what we'll do. We'll do a little bit of magic. So these two I'd have to multiply together, right? I have to multiply this and subtract the whole thing. Multiply these two together and subtract the whole thing. When you do that, let's just jump to what it looks like at the end. Okay, so it's going to be x squared minus 3x minus 4 over the x minus 1, x minus 3. So we'll save ourselves a little bit of time in writing. We know how to simplify that, so we'll just go down to what it looks like. Now the top, the numerator, we can factor that. So let's do that next. Okay. So the top would be an x minus 4 and x plus 1. At the bottom is x minus 1, x minus 2. There we go. Okay. So now we have a better understanding as to what our boundary points are going to be. Note that there's no equal to symbol. So whatever x values make it 0, we don't want to include it. What values do we also not want to include that makes this whole thing undefined?
1 and 3.
1 and 3, right? So we don't want to include those. So I'll just put under here, that's our VA. So 1 and 3, no good. And then what makes it 0 would be the 4. We'll just make that separate. So 4 and a negative 1 would make it 0. So again, we don't want to include any of those. So we're going to have no brackets. So let's list some points. Let's put all these up here. Let's see, the smallest one is negative 1. Then we have a 1, then a 3, then a 4. We got a good bit to test, but that's okay. So over here, let's see, I'm going to pick negative 2. In between here, I'll pick 0, 2, and well, 3.5 for that guy. Oh, I forgot the end, huh? The end, I'll choose 5. I have 5 things to test here. So let me just make a table. I'm going to do it by signs again. So here's the numerator, denominator, and then both. Five, 1, 2, 3, 4, 5. Okay, we're good. Let's just take a look at the sign changes. For the first one, if I plug a negative into here, it's still negative. Negative into here would be a negative, so that gives me a positive when I'm done multiplying. Second part, same thing. Negative 2 into here gives me like a negative 3. Negative 2 into there gives me another negative. Multiplied together is positive. So if I divide these two, my answer is positive. So we'll do the same thing with the rest. So this one would be a negative, positive, and negative. Negative, negative, positive. Negative, positive, negative. And then positive going down that column. So let me just pause just for a moment. Are we okay with how I'm getting sign changes? Again, I'm not worried about what the number is, just is it positive or negative in the end? Well, I want things that are less than 0. So it looks like this interval is good, and this one's good. So just those two. So let me go ahead and shade that. So that's the second interval. Those ones are good, and then the fourth one, this one. Okay? So those are my answers. Just got to be careful that when I write this, I don't include any of those numbers. So use parentheses, not brackets. So solution set. Okay, so we have negative 1 to 1, union with 3 to 4. Doing pretty good. All right, 2 more examples. Let's try this one. I think my eraser needs WD-40. This is bad. Okay, example. Solve the inequalities. And again, we're gonna be smart about these ones. We're going to do this a little bit by inspection. we did with the other ones. We're so, I think, and I'm guilty of it too, we're so easy to like just, we know the process, we just jump into it, right? And just start looking at the problem, go through the steps. It's good to take a step back and just look at the whole thing and just reason through it. Like, you know, do I have to go through that process, or can I find the answer just by, you know, knowing just some basic properties of what I'm seeing in this expression? Now, unlike the other ones, I can't break this down any further. So this is what it is. But let's talk about some characteristics of this inequality. The bottom part, am I ever going to get a negative?
No.
No. So that's always going to be squared, right? Always positive. So am I ever going to get a 0 in the denominator? No. So I'm good. So nothing I got to worry about there. Now, in the numerator, when is it going to give me a 0?
And it's equal to 0?
When it's equal to 0, huh? Does that make sense? Okay, so let's just put that down here. So we have nothing to worry about in the denominator. And then x equals 0 is the only way that inequality is equal to 0. Okay, the only way that's going to happen. Make sense? Now, could we do the sign change again? We could, but I think we can kind of logic our way through this. So for the first one, when is this going to be 0? 0, huh? When x is 0. Okay? Now, if I were to plug a negative number in, anything negative, that would be negative, right? That's still remaining positive. So what's a negative over a positive? It's still negative, huh? So I don't want to include no negative numbers in here. So from 0 onward, we're good. Does that make sense? So let's write that down. So my solution for this guy, yeah, I could fit this, would be 0 and anything past it. Okay. Now for part B, it's like this guy. The only difference is they just say, hey, don't include the number that makes it 0. So I'm going to rewrite this just with parentheses. So 0 to infinity. Now, down here, they want it to be less than 0. We want negative numbers, right? So that's good. We'll include all the negatives. And then we want it to equal 0, so we'll include 0. So for this guy, it'd be negative infinity to 0, but we're going to include it. And then part D, that's just the opposite of it. No equal to symbol, so just don't put the bracket around it. So negative infinity to 0. Any questions on that one? Okay, let's try an application. And that's it. Look at that, we're making good time, even with me losing my notes. That's gonna look great in the video. Okay, so this, which we used, it was a long time ago since we've done one of these. So this is a vertical position of an object that's just being tossed. Okay, so just like this, well, I'm not gonna do it. With those ones. Look at this one. So just like this, marker's getting tossed, boom. That's the pathway we're taking, okay? And G is our gravity, okay? And for today, we're gonna talk about feet per second. So our gravity this time would be 32 feet per second squared. So that's what we're gonna use for our values. The other stuff will come from the actual problem. So I'll put the example underneath it. So we have a ball is thrown upward from a person's hand 5.5 feet above the ground. With a speed of 60 feet per second. So for part A, we're just going to write a model, and we're going to call it S of t. to express the vertical position of the object t seconds after launch. I like how to use the word after launch. You're just throwing it in the air, but okay. Make it sound like a space shuttle. After launch. This is just a substitution. So here's what it is originally. So S of t equals, so negative a half. Now, and the other value for g is 9.8 meters per second squared. But we're not looking at meters, we're looking at feet. So that's why we have 32 there instead. So this will be 32, and then t squared. Now v sub 0 is the initial velocity. So that's gonna be 60t. And then s sub 0 or s sub 0 is gonna be our initial position, which is 5.5. Okay? There's only one step remaining with this. Just take half of 32. So this would be negative 16t squared plus 60t plus 5.5. So for this specific problem, that is where my projectile's going. That's the path of it. So you tell me a time you want to know, I will tell you exactly how high it is. Okay. Now, part B. This is where the inequality comes into play. Because right now, there's no inequalities. So for part B, determine the times at which the ball is above a height of 49 feet. Okay? So when is it above that? Let me just draw a picture over here, just so we get an idea. Okay, so let's say there's my parabola, something like that. Well, if 49 feet is right here, then it could happen twice, huh? Right? It could achieve that height of 49 feet twice. So that's something we have to consider, okay? If 49 feet was up here at its vertex, it's only hitting it once. So that's another situation to consider. It's always good to have like a visual. That way you know when you get to your answer, am I on the right track? So we want to know when S of t is greater than 49. So let's go ahead and tack that on to our equation down there. So negative 16t squared plus 60t plus 5.5 is greater than 49. Just like the other examples, set it equal to 0. Make it easier on yourself. So we'll subtract the 49 over. And we get minus 43.5. So now, solve using any method, because that's a quadratic, right? So you can solve a quadratic any way you'd like. With a decimal, I wouldn't use complete square. I just wouldn't do it. I'm going to use quadratic formula. And the reason why I'm solving this now is I want to figure out when is it equal to 0, right? Because I don't want to include the zeros. I just want to include when things are greater than 0 at that point. So here it is. So t is equal to negative 60 plus or minus square root 60 squared minus 4 times negative 16 times negative 43.5 over 2 times negative 16. And put it this way, you're going to get some numbers that are not exactly nice to work with, and that's okay. Nothing wrong with that. So t is equal to negative 60. Now when you simplify the square root, you're going to get 8/16. And then we're going to get 2 times. Okay, 2 times. And the 2 times are going to be roughly 1 second. I did round for that, by the way. And the other one was 2.77 seconds. Okay. Yeah, I got space. We're gonna do it. So let me go ahead and just draw a little number line here. So 1 and 2.77. You can probably guess what range of values is gonna be above 49 based on the graph I just did there. But still, let's act this out. Let's find some test points and go from there. So for this one, I'm gonna test a 0. In between here, I'm gonna test 1.5. And then outside here, I'm gonna test a 3. Okay. Now, I don't have any factors. You know how I did like the sign table, just to see if the signs are gonna be positive or negative? I don't have that here. So I gotta go back to the first example. That method I used to figure out if it's greater than 0, I just have to plug it back into here. That's all, okay? So let's do that. If I plug 0 into here, those are gone. I have a negative, so we'll just put a negative up here. Okay, so that's not greater than 0, so guess what? We don't want these guys. Okay, if I plug in a 1.5 into here, ends up being positive, which is good. So this guy, little smiley face, we like what we're seeing here. And if I plug 3 in and simplify into the original there, I'm gonna get a negative value at the end, and that's no good, okay? Because I only want it when it's greater than 0. So right here, those are gonna be my values, okay? Now, look at the original. I don't want it equal to 0 here, or in other words, I don't want it equal to 49, just does it hit, is it bigger than 49? So when I write my answer, I'm gonna put parentheses, right, not brackets. So my solutions, my solution set. Now here's where it's a little weird. See how I rounded things? You don't want to leave it as a rounded answer. So what I'm gonna do is rewrite this in my solutions. Okay, so it's gonna look like the following. So it's gonna be negative 60 plus the square root of 816 over negative 32, and then negative 60, oops, not plus, that should be a minus first, plus the square root of 816 over negative 32. So that's in between, that's what these two values came from, these two equations. So it's in between it. The reason why we do that is just for better accuracy. So that way if someone wanted to see what the actual number is, they can crunch the numbers and see what that is rounded, okay? If we just give someone rounded answers, they don't know where it came from, and then they can't confirm if it's right, which is no good. That, my friends, are inequalities.